this before I forget. Haha. All right. So I guess I should give myself some room, but I didn't think ahead. So let's see if I can snag all this. Put her down there and then zoom back in. So we finished regression. Well, we finished what we will see of regression last day. So not very much, but pretty fun, right? Once you get the hang of it. So our final exam is on December 15th from 1 to 4. I want to say in E308 and 310 or some mashup. 308, thank you. 308 and E309. So we're sharing with the other section, and you can go to either room as it stands, but I'll talk to Susan and see if she wants to kind of, she teaches the other section, of course, and so if we want to kind of let you mingle, or if I have one of the rooms and Susan has another one of the rooms, there'll be signs, and so follow the signs. You'll want to make sure that you write my final exam because it's catered to you and us, how we approach the course. And so that'll be good. Just as a quick note, I have a final from 9 to 12 the same day. And let me just move my pen around. So I will not be available before the exam. Usually I like to be available in case you have any questions, last minute things you just want to clear up before you head in there. Right, and so you can text me or email me, but no guarantees depending on how busy the other final exam is. Sometimes if I'm answering questions the whole time, I never get to check my phone, but so no guarantees, but just so you're aware, right, I'm not available in advance. What else? Okay. Okay. Any questions before we start? So today I want to do a final exam overview. Now these are kind of somewhat subject to change in terms of the marks. I was just giving, so these are approximate marks in green. Okay. So throwback to test 1. Oh, when I pasted these, they're just off the lines. That's annoying, but oh well. Right, so, and I'll do them in chronological order, right, how we saw things, with the exception of the inference questions, because part of your job is being able to read a question, figure out what type of question it is, and then apply the correct inference formulas, right? I made you do a fire drill version on question 4 on test 2, right? And so that, but you have to actually answer the questions. And so that's going to be later, but this is on from test 1. Visualizing and summarizing data. That's where we have things like what's the numerical variable, what's the categorical variable, how would you summarize the center, the spread, if I give you a histogram, right? All those should feel easy now. Maybe you have to refresh a little bit, but let me just go in and mute everyone, but also open the door. Hey, it was the other room. I thought I was being so good. I'll just mute everyone, I don't know. Just in case. Who knows? I need to set that setting. It's too late now. I'll put it off till January. This question 1 will be multiple choice, right? So just similar to test 1, right? Do you know it, do you not? 1.5 IQR rule to figure out if there's outliers, all that is fair game. Okay. Then we have question 2, and I'm going to put it out to you guys. You can do a probability question using a tree diagram. So from test 1, so this is still from test 1. Oops, I guess that's a different question. From test 1, we can do probability questions using a tree diagram, right? Or with a contingency table, and I'm taking requests. I'm only going to do one of those types. They're the same-ish. Sometimes building the tree diagram, I feel, is a little bit harder. So I'm leaning towards the contingency table, getting a nod and a half. Okay, I'll take it. Sold. So no tree diagram. Although pretty fun with the gift cards, right? It reduces the number of gift cards. That's the one that we had on test 1. You can do that for practice, right? And see that the same types of questions I could ask for a contingency table, right? But I'll give you the information as a contingency table, right? A two-way table like this of 2 categorical variables, right? We can still ask conditional questions, right? So things like if the partner's eyes are blue, then what's the probability that they have blue eyes? That's from your assignment. Those types of questions, right? Then we're going to move into Z-scores. Now, I can't remember which order we introduced these in, Z-scores or binomial. It's all a blur. They're both on test 1. At this point, the Z-score questions, right? Something follows a normal distribution. What's the probability that something is less than this or greater than this or between 2 things? What are the top 10% of weights, right? Working it backwards. Those are all options for a Z-score question. Those are all relatively easy now. We were just doing those to build up to p-values, right? Crazy. And so I'm only doing 4 marks there. I guess I should mention the marks here. So roughly, right, this is kind of an approximation, 10 for multiple choice, and then 8 for the contingency table. Maybe that's a little bit much, but that's okay. If it's fewer, it's okay. 4-ish for the Z-scores, right? Then we're going to do a binomial question. So I give you the probability of a success. Can't remember what the test 1 question was. Let me go there. Test 1. Oh, he has a 0.75 probability of making a sale with each client he meets. What's the probability that exactly 9 out of 12 randomly sampled meetings result in a sale? That's the binomial, right? So you have to recognize that it's a binomial question, right? And as soon as you see, I'll put the word exactly in part A, because the only way to calculate exact probabilities is through the binomial. So that's going to be your clue. And then once you know that you're in a binomial question, right, then you can recognize that, okay, I have to use the binomial formula for this entire question. And then we can find the mean and the standard deviation. I had it as a bonus on test 1 because we hadn't had time to cover it, but we do have to have it on the final exam, okay? So it was a bonus, now it's real. Ugh. Okay? But we are now used to checking these conditions, right? NP has to be greater than 10, and NQ has to be greater than or equal to 10. We're used to checking those conditions now for probability questions or proportion questions. And then you can use Z with the mean and standard deviation that I just made you find, right? And that's how you use the normal approximation to the binomial, right? You can find a Z, and then from a Z, you know how to find probabilities, right? Or you can brute force it if you want, but I said, no thanks. I don't want to do that. Sounds terrible. You can, but I don't want to. Okay. So that's what I mean when I say binomial and the normal approximation. So approximately 8 marks for that. Yeah. 2 each, right? 4 questions. Right. Here's where it gets a little bit dicey. 30 marks, 30 marks. Oh boy. Uh-oh. That's a lot of inference. Inference for proportions. What are the options here? For proportions, we could have 1 sample proportions. 1 sample for proportions. We could have 2 sample proportions. Or chi-squared goodness of fit if we have more than 2, right? So chi-squared goodness of fit, which you had to do on test 2. So this is getting into test 2 territory. You had 1 of each on test 2, right? A 1 sample proportion. On test 2, I mixed it up a little bit. You had to start with a 2 sample proportion, then a 1 sample proportion, then a chi-squared goodness of fit test, right? Part of your skills now is reading a question, figuring out what type of question it is. So they're not going to be in order. Now on the final exam, what am I going to do? I'm going to mix in some means questions. What type of means questions do we have? We can have 1 sample mean. We can have paired data, right, which was different. So paired, which is technically 2 samples, but it's a special case of 2 samples where we reduce it to 1. Or 2 independent samples. Maybe I'll just say 2. Yeah, 2 independent samples. Besides in question 4 on test 2, I haven't tested these yet, right? And so I'll be kind of more into looking at these and making sure that you're doing all right with the inference, right? So roughly 10 marks each. Okay. Usually confidence intervals questions are worth a little bit less than hypothesis testing for obvious reasons. And so notice that it's confidence interval or hypothesis testing. As a note though, so here, I forgot to write this note up above, but if I make you do a confidence interval, I could also get you to use the confidence interval to informally test the hypothesis. So that's where you check to see if the null hypothesized value is in the interval, right? And so I could do that. I'm not going to make you do it for every confidence interval that I get you to do, but I'm allowed to ask you, right? What's another thing? If I make you do a 1 sample and kind of a clue, I guess, if I make you do a 1 sample proportion confidence interval, I would also get you to do a sample size calculation. And sample size, which you did on test 2. Right? And so a couple of different ways that we could mix things up, but not terribly, right? And so I guess that's kind of a clue for your one sample proportion question, it's going to be a confidence interval. And I am going to make you do a sample size calculation, right? Because it's the only time that we test the sample size calculation. So that's all we got. Chi-squared goodness of fit has to be a hypothesis test because we don't do confidence intervals. So really narrowing down what the options are, right? I guess the only wild card is the 2 sample proportions. I already tested you on a hypothesis test. I don't know. I haven't decided actually. It's going to be whatever question I can come up with that fits the theme. A theme. I told someone about our meerkat test. I was like, oh, well, was it themed? What was it themed? Of course it was themed. Wouldn't have a non-themed test. Can't do it. For the means, right? It really is a wild card. One sample paired, very similar, right? So I'll do opposites, but I haven't decided which one's which, and I wouldn't tell you anyways. So, and then 2 independent samples is more work, right? Because you've got information from 2 groups, but not too bad once you get the hang of it. Finally, so roughly 10 marks each, roughly. I'm not, set in stone on these, but just so you know where to focus your studying, it's feeling like you should focus on inference, yeah? Okay, as long as you're getting that feeling, then that's what I'm going for. And I'll put this on the same page. For regression, I'm going to do roughly 8 marks. Now, that's a lot, but it's also relatively easy compared to inference. And so I like to kind of inflate those marks. And of course, if it's just terrible at the end, then I'll kind of make adjustments. I want you to have good marks, right? I want you to do well in this course. And so I'm not trying to set you up, but I do inflate these marks because the questions are relatively easy, okay? And so I was thinking about it, and even though we introduced how to calculate the slope and the intercept last day, and it's on your formula sheet, how would you feel about if I just gave you the Excel output and you could grab the slope and the intercept from there, make it like a multiple choice scenario? Getting some nods? Okay, I'll take it. So I'll do that. Given Excel output, pick the slope and the intercept, and maybe I'll put the regression notes multiple choice. I'll copy this to the next page because I do want to talk more about the regression. I try to aim to have it out of 100. I might kind of do some weird stuff because 100's nice, right? But there, that's it. That's all you need me to know, Emily? I know, crazy, right? It is, it really is. Any questions before I talk more about the regression questions? Yeah.
So for our inference question, for the inference questions, you have the ×3.
Yeah.
Is that there's 3 possible questions, or there's going to be 3 questions on each?
Oh, no. Oh, gosh. I don't want to mark that, but also no.
Okay.
So of these possible types, I'm going to pick 3. I'm not going to do duplicates. That's crazy. So it'll be some mashup.
Oh, yeah. Sorry,
Yeah. So,
So if there's
so basically one of each
one of each type.
type.
Okay.
Yeah, either a confidence interval or a hypothesis test, right? No worries. Yeah, it's already feeling like a lot for me to mark. Don't you feel bad? Oh, but then I'll be done. Any other questions about that layout? Is there anything you want to be tested on that I haven't included? What about that one thing that we did? No takers, huh? Okay. Let's see here. So in terms of regression, what I'm expecting you to know, right, because it is the most recent thing and we didn't get to spend a ton of time on it, right? But if I give you Excel output, and how about, I'll tell you this, and given the scatter plot, what are some things that I could ask? I could ask you for, well, let's start itty bitty. What are the response and explanatory variables, right? So identify the response and explanatory variables, right? The response variable is the y and the explanatory variable, I guess I should link it to the explanatory variable, is the x. Right. Wow, that's very sloppy. There. And sloppy. Those should be easy marks, right? How about if I get you to describe the relationship? Remember, you have to touch on 3 things, right? You have to talk about the shape. So is it linear or non-linear? It's going to be linear because otherwise we can't fit a straight line to it, right? And the direction, is it positive? Is it negative? And then the strength, right? Is it strong or weak? Or you can do some fancy version of that, moderately strong, moderately weak, whatever. And so maybe describe the relationship. Right. Shape, direction, and strength. So you have to touch on all 3 things. I guess I could make that a multiple choice question as well. Right. Do you want multiple choice for these? No. You could just treat it as a normal question and then just pick the right one. Isn't that what all multiple choice are, though? I know. Only because I feel like if I do that, then it could be multiple guess. If you have no clue, you could still, potentially get something out of it. So sometimes I like to do that. I'll just make a note here. Multiple choice, probably. And if you don't like it, you can just ignore the choices until the end. Okay, so what else could we do? If I give you the output, right? What's the slope, right? That's another multiple choice. How about a non-multiple choice? Interpret the slope, right? So that's where you look at the least squares regression line. It's on your formula sheet, right? You can use that as your guide, and we can say, okay, for each unit increase in x, and I'm gonna be looking for that unit increase in x, okay? And then once I see that, I'll probably just mark it right and move on, right? But for each unit increase in x, right, we expect to see a slope increase in the predicted value of y. That's really just a matter of memorizing and putting it on paper. Ideally, understanding as well. Interpret the slope. Now, the reason I want to do multiple choice for the slope is because as long as you interpret whatever you chose for the slope, I'm happy, right? So even if you have no clue what the slope is, as long as you pick something and you apply the interpretation to that value, that's fine. Okay. And so then find the y-intercept. That's a multiple choice, little bitty. There. Because then I get you to interpret the y-intercept. Again, just whatever you chose as your y-intercept in the previous part, just use that, right? So even if you're completely lost or just guessing on this page, then you can still get a good amount of marks. Interpret the intercept. Is it meaningful? What was that getting at? Interpreting the intercept. So interpreting the intercept is the intercept is the predicted value of y when x is 0, right? And so then is it meaningful? You're really asking yourself, can x be 0? Right? This is, there's usually a more correct answer, right, that I'm looking for. But as long as you argue that, yes, x can be 0, right, whatever x is, right, I can have a home with 0 square feet. Can you? If you tell me that you can, then you should say, yes, it's meaningful, right? If you tell me, well, a home doesn't exist if it's 0 square feet, for example, right, then it's not meaningful, right? So just base your argument around, can x be 0? Okay. What else can we do? Use the regression line. Pardon?
Residual value?
Oh, that's too much work. We could. Sounds fun. Nah. How about we just make a prediction, right? So use the line or the least squares regression line to predict y for a given value of x. The least squares regression line is really just a fancy way of saying y hat is equal to, I think we do b1x plus b0 on your formula sheet. I can't remember. You've got the slope, you've got the intercept from the previous parts. Just use those values that you told me were the slope and the intercept. Okay, as long as you follow through. And this is where I'm not going to make it multiple choice, because I'd have to have like mental if-then statements for the choices, and that's really hard. So I would do multiple choice, but it would be really hard for me to follow through. And that's the most important part, right? Just use the slope from the earlier part, use the intercept that you picked, okay? And then plug in whatever value of x I give you to predict the value of y, right? So here, use b1, so the slope, and b0 from earlier. And for that reason, I'm not making a multiple choice, although it could be. But then, yeah, it gets weird. Okay. How many marks is that? Should we do one each, the response and the explanatory? That's 2 already. Describe the relationship. 3. Because it's multiple choice, so it's only 1 mark. Tell me the slope, that's 5. Interpret the slope, I'll do 1 mark. Whoa, lost track. 1, 2, 3, 4, 5. Okay, 5, sorry. 6, 7, 8. Nine. Oh, I have an idea. I usually have 2 options here. Remember? So we're already at 8, but I want to add 2 more questions to make it out of 100. So how about make it out of 10, make it out of 100, because this is another mark, right? So now we're at 9. The 10th question, do you want it to be, I know what I want it to be. I was going to give you options, but not that cool. How about an R squared question? R squared. Remember, the R squared is the proportion of variability in Y explained by the least squares regression line on X. Say that again. As soon as you see proportion or percentage, because they're the same, right? Variability. You know it's going to be R squared. And once you know it's R squared, right, there's going to be a long blurb. Find the percentage of variability in Y explained by the least squares regression line on X. But what do you have to do? You have to take your correlation and square it. And that's your R squared. Kind of confusing. It grows up into a capital R squared. You'll have the correlation, right? So from the question, I'll give you the correlation. And I think that's nice, maybe. Could I be mean with this question? Should I flip it? What if I tell you that 78% of the variability in Y is explained by the least squares regression line? So now I've told you that 0.78 is R squared. The follow-up could be find the correlation. What would you have to do? Take the square root, right? Make sure that you're working with the decimal, right? Or the square root of R squared is R. Plus minus R. So that's why it's a little bit rude. But also, if I've given you the scatter plot, which I have, right? Given the scatter plot, then you know if you have a positive relationship, then you use the positive value for R. If you have a negative relationship, you use the negative value for R. And I think I'm leaning towards this one just to show off a little bit. And so I'll do this one. So given R squared, find the correlation. But as a trade-off, should I make a multiple choice? You can ignore the choices. Multiple guess. Don't leave any multiple choice questions blank. It kills me inside. You didn't pick anything. You could have picked something, and it happens a lot, or like more than I ever want. So just pick something. Pick something. All right. Any questions? I'll do a little jot down of the marks breakdown. So here, I'll call this 2 marks, 1 mark, 1 mark, 1 mark, 1 mark, 2 marks because it's 2 parts. 1 mark, 1 mark. 1, 2, 4, 6, 8, 10. Nice. Just like we committed. Any questions? Okay. So I will give you a practice for the final. My fear is that I've used all my good practice for the test questions for practice 1 and or for test 1 and test 2. So I do want you to reuse those because I kind of picked the cream of the crop and didn't care about later Emily. And now later Emily is not loving that. Coming up with those questions is really hard. And so I want you to use, so I'll even say recycle practice for test 1 and number 2, especially number 2, right? There were a lot of inference questions on there. I'll build it out because I don't think I had questions for 2 sample means on there. Can't remember. Did I? Maybe I don't even have it in here. I don't. Oh, what's another thing we could do? I could. How about I do that? I still haven't made the solutions to the test 2, but I will. Here, oh, whoops. You just had to give me the null and alternative hypothesis and tell me if it's a one-sided or a two-sided test. The reason I'm making you do that here, where it's kind of low stakes, is because that's where people struggle the most, right? So if we've got this practice under our belts, right, then we can do it for the final exam. And that's the only one that matters to me, right? And so I know it all matters to you. But what can I do? I could actually answer these questions, right? Pretty sure I have all the information that I need. I'll use a default alpha level. Why not? I can do that. And I can answer all these questions completely, which some people did in the test. And I had to write at the top, you must think I'm so cruel. Why would you think that? And how did you have time? So here, right, very good practice for just fire drill, reading a question, figuring out what type of question it is, and then figuring out your null and alternative hypotheses. Everything else is just kind of, you follow the formula sheet. You want to get to that point where you think, and then you just follow the formula sheet, right? That takes practice. But right, each of these is a hypothesis testing question. Could rephrase it as a confidence interval. I'll just answer the hypothesis testing questions because they tend to be where people struggle the most, right? But yeah. Any questions? Guess we could get going on these. Or what else? Oh, there was something else I wanted to show you. I'll put this on the same page because I had nothing else to do to write there. In case you haven't seen it on Moodle, I did make this last year, and so some changes have been made, but in general, oh, I'm realizing all types of things that I've forgotten. So I did post this decision tree. It's very itty bitty here. First, you have to decide, do you have a proportion question or a mean question, right? Do you have numerical data or do you have categorical data? And then you've got more decisions to make. Do you have 1 sample or 2 sample or 3 or more samples, right? And so you could do a hypothesis test or a confidence interval. I've got the assumptions outlined here. How would you feel about just having a list of generic assumptions and you have to check the ones that apply instead of actually having to check them all. I think that's a reasonable trade-off. So I'll make a note of that here. Do I have room? You do not have to check assumptions on the final exam, but I want you to keep reading, I guess. But that looks weird. Check all that apply from a generic list. Check all that apply from a generic list. Yeah, it'll be like just a list of assumptions that you could check and probably just 1 mark. Very, very minimal. Because we tested it on test 2. And so now there's so much material, right, on the final exam. I don't want you wasting brain space on it. If you remember it, just check the random box always. That's a safe bet, right? And then just do the ones that you remember, but don't waste any time kind of memorizing it anymore. Okay? I did want you to do that for test 2, but that's over now. And we can say we did it. There. Oops. Okay. Assumptions. What else did I want to talk about? Oh yeah, so you've got this decision tree. I am using an old version of the formula sheet, but you can just ignore the alternative hypotheses. Everything else is the same. I eliminated them because they were a little bit misleading because the 2-sided test, so the not equal to is the default, right? But then you change it depending on the question. And so I removed it, but in general, it's all the same. And then I have the summary. If the p-value is less than the significance level, you have enough evidence to reject H0. Don't forget your conclusion in terms of the question. That's 1 mark, right? Your conclusion is 3 marks always, right? First, compare your p-value. Tell me what it is. Compare it to the alpha level, right? Tell me what it is. Is it less than or is it not less than the alpha level, right? And then what does that mean in terms of your null hypothesis? Do you have enough evidence to reject H0 or do you not have enough evidence to reject H0? 2 marks. Then your conclusion in terms of the question. Yeah. Let's see here. And I put Snoop at the top just in case. Any questions? How's it feel? No new material. Should we do some practice problems? Why not? Let's see. Since I have them ready, we can do from question 4. Now, I think some of these values might be slightly different. If you had the other version, it's totally fine. It's the same idea, right? And so the answer is basically the same. What do we want to do? Read these and figure out what type of question it is, right? That's our first job. And so the coffee shops recently started selling vegan donuts. Marge is not sure if they're worth selling. She decides that if she sells significantly fewer than 32 vegan donuts per day on average. So right away, when I see this word average, I know it's a means question, right? And so pay attention to those words. Often I'll say proportion in the question, right? But also if I don't give you a mean and a standard deviation, it's a proportion question, right? By elimination, then she'll stop selling them. She takes a random sample of sales from 19 days and finds the mean number of vegan donuts sold is 27 per day. So now we have a mean, a sample mean, and with a standard deviation of 4.1. So we have a sample standard deviation. Is there evidence that the mean number of vegan donuts sold per day on average is less than 32? So first, let's establish what type of question this is. It's a one sample mean question. Which tells me on the formula sheet, once I've decided that, I'm stuck using only these formulas. These sampling distributions are just fluff. You can ignore them if you want. They're technically supposed to be there, but we really only use the confidence interval, the null hypothesis, and the test statistic. For a t, we need to know the degrees of freedom. So from here, if I have to give the null and alternative hypothesis, I know in general it's going to look like the null hypothesis has to look like mu is equal to mu naught, where we have to figure out what value we want to compare our sample mean to. So from here, right, is there evidence that the mean number of vegan donuts sold per day on average is less than 32? We have a sample mean of 27. Is that significantly less than 32? So the value that we want to compare this to is 32. So therefore, our null hypothesis has to be mu is 32. The alternative hypothesis, well, whatever I have here and here has to be the same. So I can start there. Right. And then the only thing that changes is the sign in the alternative hypothesis. And we want to know if it's less than 32. So our alternative hypothesis is that mu is less than 32. Now, the key is that we do all our testing assuming that mu is 32 until we find that 27 is actually too far from 32, right? And so then we have enough evidence to reject H naught. Can I do this? Maybe. I'll need more room. So that's step one. Step two is calculate the test statistic, x bar minus mu naught over s over root n. Could have done this one for the bonus, right? Calculate a test statistic from any one of these. So, okay, let's see here. T is, now this is where you want to make sure that x bar is 27 and s is 4.1 and n is 19. So then we have, how far is 27 from 32 if the standard error is 4.1 over the square root of 19? Who knows? I didn't actually check these values. Might give you huge test statistics, but that's okay. 27 minus 32 divided by 4.1 divided by the square root of 19. Make sure you use your brackets. I get a T of negative 5.3157. T, I'm gonna round to 3 decimal places because that's what my T table has. I've calculated a T, I need to use the T table. Okay, it's gonna get weird. Can I do? What can you do when you live in a shoe? I should have put this on a fresh page. You know what? It's not too late. I'm just gonna copy this whole thing. Oops. As an image. There. No harm, no foul. A little bit messy. It's okay. So now that I have T, right, I need my degrees of freedom is n minus 1, which is 19 minus 1, which is 18. Using the T table, right, I can figure out what values surround T. And so the absolute value of T equal to negative 5.316 is between 2 values. I don't think it's on the table, but that's okay. We can handle that. Make sure you're on the T table and you need 18 degrees of freedom, which is one of the lines. It maxes out at 3.922. That's where we stopped caring. Anything bigger than that has hey, I forgot to say if it was a one-sided test or a two-sided test. We need that now for the p-value, the one-sided test, because I only care about one extreme, right? If it's not equal to in your alternative hypothesis, then it's a two-sided test. If it's less than or greater than, then you only care about one side, so it's a one-sided test. Now, I will say if you get it wrong in the alternative hypothesis, I'm looking for you to follow through on that, right? So you don't want to go for a one-sided p-value if you told me that you were going to do a two-sided test, right? And so that's what I like the least is when you flip-flop and do a mix and match. I'd rather that you were just consistent on how you, on how you solved it. Let's see here, paste image. I want to do something weird. For when I copy, delete, bring this in here. If you wanted to, we could spend some time completing the table. What would this look like? Here, after 3.92, I'll do a nicer, no, that's like a weird infinity. How come I can't draw infinity anymore? There. The next stop would be infinity, right? Kind of a weird leap to go from, well, it's somewhere between 3.922 and infinity, right? But that's the leap that we're making. And so that's what we're going to say. 5.316, take the absolute value, so you drop the negative, is somewhere between 3.922 and infinity. So that's what we're going to write down. And infinity. So at infinity, how much area do you have in the tail past infinity? At that point, you have 0 area in the tail, right? And so you do have, right, even if you multiply it by 2, you still have 0, right? And so the probability, the p-value in the tail at infinity is 0, okay? But not until you reach infinity, which you'll never reach. And so that's why we can't have a probability of 0, but somewhere between for our one-sided p-value, the probability, the p-value is somewhere between 0, right, and 0.0005, very, very small. Therefore, the one-sided p-value, and I use the same setup as above, right? What I'm looking for, I write in the middle, I use less than, so I don't have to think about it. The only switcheroo I have to do is write these from right to left, so 0.0005, very small. I do want to go back up here and say that this is a one-sided test because of the less than.
It was a less than or equal to, would that make it the two-sided?
So the equal sign always has to be in the null hypothesis. And so, but if you have a not equal to, then it's a two-sided.
Okay.
Yeah. Nice. Now, our conclusion, same sentence structure always, right? Showing off all the components that you've built up. So now I'll put that there because I feel like I'll need these lines. Since the p-value, we just said it's a one-sided p-value, so why not write that down again, right? Since the one-sided p-value is between 0 and 0.0005, it's less than the assumed alpha level of 0.05. It wasn't given to me, so if I don't have a p or an alpha level given, I just use 0.05. It's my default. Is less than our assumed alpha level of 0.05. That's your first part of your conclusion, right? This is 1 mark. Compare your p-value to the alpha level. Is it less than or is it not less than? Right, 1 mark. Since the one-sided p-value is between 0 and 0.005 or 0.5 is less than our assumed alpha level of 0.05, all that, some of that feels optional. It's not. I want to see it all. We have enough evidence to reject H naught. And if we're rejecting it, we can reject it in favor of the alternative hypothesis, in favor of HA. This, right? Your conclusion in terms of the null hypothesis, you only have 2 options. You either have enough evidence to reject H naught or you do not have enough evidence to reject H naught, right? I don't want you going rogue. Those are your only options for 1 mark. Stay consistent, right? If for some reason you mess this up, so since the one-sided p-value is between 0 and 0.0005, and then if you for some reason tell me is not less than the alpha level of 0.05, that happens, right? Follow through on that. If it's not less than the alpha level, then you do not have enough evidence to reject H naught, right? It's incorrect in terms of the question, but it's good in terms of the follow through. Okay, and so I'll deduct a mark for kind of messing up your comparison to the alpha level, but then as long as you follow through on that, you're safe. So we have enough evidence to reject H naught. Therefore, can I say she should stop selling vegan donuts? Because this is my page break. She can stop selling. It should be more proper, but any sort of conclusion is fine, right? Usually I would say, and this is 1 mark. right? Usually I would say just reword the question as an answer. Is there evidence that the mean number of vegan donuts sold per day on average is less than 32? There is evidence that the mean number of vegan donuts sold per day on average is less than 32, right? That's your conclusion in terms of the question. And that's what you would be paid to do. So that's why it's the most important thing, arguably. Okay. Any questions about that one? Can go through the rest, but I also want to save some of those question fours so that you can read through them, figure out what type of question you have. And so, I don't know, feels weird, but should we call it? Is all this fun stuff going on downstairs? Is it game over? Don't be too sad, okay? Any other questions before? I know this is like the one class that you don't want to end early, probably. Although maybe you're over it.
So I have a question.
Yes.
From the top, you said that we will need to memorize it again. And another page before the example. So that's, you said that we memorized for the past two, we will need to memorize it again.
The assumptions.
Assumption, that's the top part, right?
Yeah.
So like a N.
Yeah.
the
So for
sentence.
proportion questions especially, we have to check that we have at least 10 successes and 10 failures. But I'll just have a generic checklist, right? Expected number of successes is greater than 10. Observed number of successes, so you have to keep those straight, right? Observed is for confidence intervals and expected is for hypothesis testing. And then it has to be randomly selected, right? And so you still have to kind of know the assumptions, but I'm gonna only make it 1 mark, so
So just don't need to write down.
No. Yeah. So that's good. Oh, and to just before we finish, I do want to talk about, okay, so we talked about the end of this table, right? Has a p-value of 0, 0 at infinity, right? And that's infinity across the board. What's on the other side? 0, right? Because it's the absolute value. So the smallest z I could have is 0, or t is 0, whatever, they're the same-ish, right? So if I have a value of 0, or something between 0 and 0.688 or 0.674, depending on the scenario, what's the p-value? Yeah, 0.5 for the one-sided p-value, and 1 for a two-sided p-value. Because you're right in the middle. How much do you have in one of the extreme tails? Well, just one of the tails, doesn't matter which one, 0.5, because that's a property of the t and the z. But also, if you wanted to look at both tails, then the p-value would be 1 at 0, right? So you can have these bounds just in mind. And now I'm out of things to say, if you can believe that. Okay, I'll stick around in case you have any questions you want to talk about or work through. But with that, I release you and have fun studying. And thank you for a great term. I'll stop this.